Exponent laws, practice number 2. Question number 1. Evaluate and show all the steps. Remember, when you have powers with the same base, adding the exponents only works in multiplication. If there's a subtraction sign, you have to leave that power alone. So the 3 to the 4 will have to stay the same, but I can add the exponents on 3 to the 2 times 3 to the 1. So this will be written as 3 to the 4 minus 3 to the 2 plus 1, which will be 3 to the 4 minus 3 to the 3. Again, since there is a subtraction sign, I'll have to evaluate each power separately and then subtract. So 3 to the 4 is going to be 81 minus 3 to the 3, which is 27. Subtract and you get your final answer of 54. For question B, 3 to the 4 times 3 to the 2, I can add the exponents because this is multiplication. But the minus 3 to the 1 will have to stay the same, as I cannot add exponents when there's a subtraction sign. So this can be written as 3 to the 4 plus 2 minus 3 to the 1. 4 plus 2 is 6, so this can be written as 3 to the 6 minus 3 to the 1. Evaluate each power separately because there's a subtraction sign. 3 to the 6 is going to be 729, and 3 to the 1 is 3. So 729 minus 3 is going to give me a final answer of 726. For C, 3 to the 4 minus 3 to the 2 divided by 3 to the 1. Again, there's a subtraction sign, so the 3 to the 4 will stay the same. With division, I can subtract the exponents. So this will be written as 3 to the 4 minus 3 to the 2 minus 1. 2 minus 1 is 1, so this will be written as 3 to the 4 minus 3 to the 1. Again, there's a subtraction sign, so I will evaluate each power separately and then subtract. 3 to the 4 is going to be 81, and 3 to the 1 is 3. 81 minus 3 will give me a final answer of 78. And for question D, I can subtract the first two exponents because this is division. So 3 to the 4 divided by 3 to the 2, I can subtract. There's a subtraction sign after it, so the 3 to the 1 will have to stay the same. So this can be written as 3 to the 4 minus 2 minus 3 to the 1. 4 minus 2 is 2, so this can be written as 3 to the 2 minus 3 to the 1. Again, since the subtraction sign is there, I'll evaluate each power separately and then subtract. 3 to the 2 is 9, and 3 to the 1 is 3. So 9 minus 3 is going to give me a final answer of 6. Question number 2. Evaluate and show all the steps. 2 to the 5 times 2 to the 4 minus 2 to the 6 times 2 to the 1. Since this is multiplication, I can do the first two and I can do the second two. But there's a subtraction sign that separates them in the middle, so I'll have to do each of these separately. So 2 to the 5 times 2 to the 4 is going to be 2 to the 5 plus 4 minus 2 to the 6 plus 1. This can be written as 2 to the 5 plus 4, which is going to be 2 to the 9, minus 2 to the 6 plus 1 is 2 to the 7. Again, since there's a subtraction sign that separates them, I'll have to evaluate each separately and then subtract at the end. 2 to the 9 is going to be 512 minus 2 to the 7, which is 128. And 512 minus 128 is going to be 384. And question B, 3 to the 2 plus 5 to the 0 times 5 to the 2 minus 2 to the 3. In this example, I have a plus sign, so the 3 to the 2 will have to stay the same, and a subtraction sign, so the 2 to the 3 will have to stay the same. With multiplication, I can add the exponents for 5 to the 0 and 5 to the 2. So this can be written as 3 to the 2 plus 5 to the 0 plus 2 minus 2 to the 3. This will be written as 3 to the 2 plus 5 to the 2 minus 2 to the 3. Since the bases aren't the same, and I have a subtraction and an addition sign that separates them, I'll evaluate each separately and then solve. So 3 to the 2 is going to be 9, plus 5 to the 2, which is 25, minus 2 to the 3, which is 8. 9 plus 25 is going to give me an answer of 34. And then next, I'll have 34 minus 8. And 34 minus 8 is going to give me a final answer of 26.